Hello, viewers and listeners. Today we are talking about anti-aging gene therapy with Liz Parrish. Liz Parrish is the founder and CEO of BioViva Science USA. BioViva is committed to extend healthy lifespans using gene therapy. Liz, known as a woman who wants genetically engineer you, she elongated her telomeres. Also, Liz, entrepreneur, innovator, author, a leading voice for genetic therapy, and educational podcast hosts. Guys, I strongly recommend to subscribe on her channel and follow BioViva News. Liz, hello and welcome to my channel.
Hi, Alexandra. It's so wonderful to be here.
Thank you, Liz. Thank you. So we are curious, where are you now with BioViva? What project or projects are you working on now?
So BioViva, anyone who's followed the company, BioViva has taken a real winding path in order to do what it set out to do, which was to get access to therapeutics to humans. So we want to get humans access to this technology, and as a U.S. company, we couldn't do that. We want people to access regenerative gene therapies and things in the regenerative realm that will actually help bodies stay healthier longer. So over the last few years, we've sort of found our ground and got running. We have an exclusive partnership with a company called Integrative Health Systems that does medical tourism, and they get patients access to the technology. And then at BioViva, we analyze the data of how those gene therapies are performing. We've expanded into DNA methylation kits that help people understand their biological age and how we can actually affect their biological age. And then we also launched something called the BioVault, which gives people a place to store their multi-omic data. And if they allow us to, we can actually analyze that data and start to make correlations and causational information between that data. So that's pretty much what we do. And then we have another arm of the company that does research and development with Rutgers University, and we're working to develop a multi-gene therapy delivery vector that will revolutionize how we do medicine in the future, and what the gene therapy that is delivered to humans in the future to treat biological aging looks like.
Great, amazing. Liz, what's the price for biological aging treatment?
So the cost of the therapies through Integrative Health Systems, again, that's not BioViva. They vary in range. I don't have the exact cost, but I know that they start at around $65,000 and they go up. It's pretty expensive technology today.
Liz, can we expect reduction of the price maybe in future, in 5 or 10 years?
Yeah, absolutely. We will definitely see a reduction in the cost as more people participate in these type of therapies. So essentially, we build therapies to scale. So if we're just treating one person, the gene therapy for one person could be $50,000 to hundreds of thousands of dollars. But if we were treating 10 people, that would go down by a percentage. And if we were treating 100 or 1,000 people, then the cost of the gene therapies become actually much more affordable for each person.
Liz, could you clarify for me, please, aging process? We are aging due to mechanical runout of our organs, cells, tissues, or due to aging program, due to aging software in our genome, DNA, RNA?
Well, I think that there's a lot of different philosophies around aging and whether it's programmed, and certainly it's in the genes. So in a way it's programmed, but it doesn't happen at the same rate in everyone. So it definitely happens in everybody, but not at the same rate. So what we look at when we're developing technology and therapies that treat biological aging is we're looking at the hallmarks of aging. Processes that are happening at the cellular level that we can affect with these gene therapies. So we look at things like genomic instability, telomere attrition, mitochondrial dysfunction, cell sensing issues, stem cell depletion. So we're looking at what's happening at the cellular level that we can affect with gene therapies when we're treating it. We are treating it with gene therapies, which essentially means we are changing the code to say live longer, regenerate faster than you degenerate. And when we're able to create the first human body that does that, that will be an exciting breakthrough for humankind, for sure.
Liz, what genetic material has been injected in you?
Okay, yeah, so hopefully over the next couple of years there's going to be a lot more, because I want to participate in more gene therapies. But in 2015 I had two different genes inserted into my cells. One was called follistatin, and it increases your muscle mass. So it blocks something called myostatin, which allows your muscles to grow. And what's great about this is that it basically curbs the effect of time. So as we age, after the age of 35, we lose about 1% of our muscle mass every year. So that's 10% every decade. So that's why as people age, they become more and more frail and fall down. So this gene keeps that from happening. The other gene therapy I took was called HTERT. It's the human telomerase gene. It codes for an enzyme that lengthens the telomeres at the caps at the ends of your chromosomes that shorten as we age. So chromosomes have caps called telomeres. Every time your cells divide, they get shorter and shorter, and that's associated with genomic instability, mitochondrial dysfunction, stem cell depletion, and when telomeres get short, your cells turn into senescent cells. And so lengthening the telomeres is an essential part of helping an organism live longer. So those were the two gene therapies I did.
Now I understand why you increased your muscle mass.
Yeah, you definitely want to do that. Dying of frailty is a real thing. My best friend's mom last year fell down and hit her head, and she died due to that injury. She died because of frailty. It kills a lot of people every year.
Liz, where BioViva and Integrated Health get healthy genes for using and injecting?
Where do we get them?
Yeah.
So they're generally sequenced. They're already known human genes. Right now, we only use human genes, although in the future, we will use genes from other species, because other animals have technology. You might want to think of the genes as technology or a program that help them do things like regenerate and be resistant to genomic instability and freezing temperatures and things like that. So, but today we just get genes from human gene banks because they're genes that we all share in common. So, and then those genes are sequenced and then put into a delivery method and delivered to you. So a lot of people ask, they say, oh, do you need to get a gene from another person to put into me? No, these are known genes that everybody has. As a matter of fact, you have the gene for telomerase in every cell of your body. It's just by evolution, it got turned off. So we're just turning it back on.
Great. Liz, what's the length of your telomeres?
The length of my telomeres today, I think, well, actually, I'm waiting for my latest telomere test, and I've been waiting for months for this to come back. The last length was 8.14, and it was an increase of about 33 years from when I did the telomere lengthening gene therapy. So my telomeres were actually pretty short for my age when I was 44, 45, and they have lengthened significantly, which is great. And I wasn't surprised that they were short because I don't have a long-lived family. We generally live to our 70s, and that's about it.
exists the optimal length of our telomeres? I mean, too short, it's aging and we are dying. Too long, maybe it's dangerous for us.
Well, actually, that was demythed in a recent paper that there maybe is not a too long. Now, when we look at things like cancer, we often look at telomerase in a different way. Sometimes cancers have long telomeres, but that's very different. When the gene is upregulated in cells, it protects them against cancer. So probably we want them to be pretty robust and pretty long in a healthy sense. So we don't know what that limit is, but it's not believed that there is a critical limit on that. Now, you wouldn't want them to extend forever, but your cells have a program so that they won't extend past a certain point.
Okay. How often person need to do diagnostic that determines telomeres?
So you should do one every year. That would be what we would suggest. And a patient who takes part in a gene therapy to lengthen their telomeres, we would actually make sure that they get a kit every year.
So, and you are planning maybe to do it after your diagnostic, maybe next year, yeah?
I want to do a lot more gene therapies. So now we offer, Integrative Health Systems offers telomerase-inducing gene therapy and follistatin. They're offering clotho now, which I really want to participate in. It increases intelligence, it protects you against cardiovascular disease and chronic kidney disease, which is something that everyone gets. And then the fourth one is PGC1 alpha, and that is to make your mitochondria more robust, more power coming out of the cells. And that's very beneficial also to a long lifespan. Every gene that we look at has increased the lifespan of model organisms.
So, Liz, in my following question, I want that you give the answer to your critics. Some of them say that this kind of therapy can lead to cancer. What can you say?
No, as a matter of fact, Bill Andrews was our scientific advisor for most of the life of the company, and he's gone on to he has a company that's doing the gene therapy. He actually found telomerase. He found the gene responsible for it when he worked for Geron, and there is no evidence that it will increase cancer anywhere. So cancer has a very different path than a healthy cell. There are 21 hallmarks that have to happen in cancer for it to become a condition. And vastly, it's driven by genomic instability. So critically short telomeres lead to genomic instability, and that's what leads to cancer. Long telomeres in a healthy cell do not lead to cancer. It actually protects the cell against cancer. And it's been proven in animal studies that animals who are actually given telomerase are resistant to cancer. They die less of cancer. They're more protected against cancer. And things like our germline cells that have telomerase turned on, which is our egg and sperm, are resistant to cancer. And organisms that have telomerase turned on in them are also resistant to cancer. So we do not believe that telomerase induction in itself causes cancer, but when a lot of things go wrong with a cell and they become cancerous, then telomerase can play a role in that cancer.
Liz, from your point of view, when a World Health Organization acknowledge aging as a disease?
Well, I wish they would do it immediately, especially with the COVID-19 outbreak, because it is showing us that mostly old people die of infectious disease. And your age is your biggest risk factor for death. And so, you know, right now would be a good time for the world to wake up to that aging being a serious disease, a serious condition that we need to treat. If we continue to try to cure cancer, alone cure heart disease, cure dementia. We will not be able to do it. We have to treat aging, and if we treat the aging cell, we will not get heart disease and dementia, and we will vastly reduce the amount of cancers.
Liz, what do you see now in genetic engineering that you even didn't expect to see 3 years ago?
One of the things that I'm really excited about in genetic engineering right now is the CRISPR technology. We use just gene therapy. We deliver a gene that's an episome. We don't try to integrate it. But with CRISPR technology, you can even edit out genes. And for things like Huntington's disease, that's going to be crucial. These people have several copies of the same gene, and they have so many copies it ends up ending their life early. So being able to take genes out is really great. Another thing with CRISPR that I like that's more recent is instead of editing genes in and out, you can actually affect the promoter of those genes and turn on genes that we might want turned on, like the telomerase gene. So instead of trying to insert the gene, we could just use the genes we have right in our cells.
Great. Liz, how can AI help you in the future to fight with aging?
Well, it's going to be crucial. As we gather more data of how genes interplay with each other, you have to realize there's like 25,000 coding genes in your chromosomes that are coding for proteins that are essential to your life. And how those genes work together, we don't fully understand yet. Plus, on top of that, there's a bunch of genes that we thought were non-coding silent genes that are actively affecting the coding genes. So AI will help this significantly by helping us understand what's happening between these genes interplay. So maybe by upregulating one gene in the future, we will know that we will actually affect 7 other genes, and we can do gene therapy more efficiently.
Liz, can we achieve an immortality?
We can, in the sense of the scientific definition. So even in the dish, when we use telomerase, we can do what's called immortalizing a cell line, not giving it cancer, but immortalizing it, making it live longer than it naturally would. And so we can definitely do that. We will be able to break the lifespan of humans and increase that lifespan significantly through gene therapy. Now, if you get hit by a bus, you are still going to die, but we can do it by the definition of science, by extending the lifespan, what might be considered unnaturally from its original lifespan.
Liz, how can someone get involved in your activity and support you?
Oh, gosh. Well, they can come to our website, which is bioviva-science.com. If they're interested in gene therapy, they can go to our partner company, which is integrated-health-systems.com. And, check out our videos on YouTube. It's BioViva Science. And, connect with us on Facebook, Instagram, and Twitter to get all the latest news that's coming out about gene therapy. I mean, it's such a robust area.
Liz, what's your message to people?
I would think, okay, so what would my message, I think you should be very excited about the future. And I think that you should look at this technology with an open mind, and don't think of it that it's just for rich people or it's just for some people. I want you to start designing your perfect body. And then as the technology grows, we will be able to do that. So we can increase your muscle mass, we can increase your intelligence, we can affect eyesight now with gene therapies. We can affect the immune system. We are working on helping you live longer, healthier lives, more youthfully in that sense. We're trying to build the first body that stays in homeostasis, that, regenerates faster than it degrades. And that technology is for you. This company was built for you. And so I want you to get really excited about that. And, what would you want? Do you want to see in billions of colors instead of millions of colors? Do you want to be stronger, faster, smarter? Or do you want maybe some technology of the future that's yet to come? You have to dream it for there to be a demand for that technology. So get excited.
Liz, thank you so much for being with us today.
Thank you for having me.
Okay.